All right, here we go. Let's do this. All right, so again, the test grades from last week have been posted. I don't know if you heard me say or not when I was speaking to the kids in here. Um, there actually ended up being no curve. The average a curve is based on how you did compared to class average, but the class average was high enough that it basically busted the curve. So whatever you see is what you actually got. I went back and I replaced any weekly assignment grades that you had that were lower than what you got. So, I mean, I'm doing everything I can to help you out. Um, this week, here's the plan. We're starting a new unit. We'll do that today and tomorrow for sure. Wednesday, I have a Kahoot planned, but that's going to depend on how much progress we make here or not. Because Thursday is when I want to go over the test. And the reason why I want to go over the test Thursday is because we have our retake on Friday. Now, the retake will be over the first three tests, but at least if I review test 3 the day before, that's at least 1/3 of the test that's being reviewed right before. Anything else is up to you to review. Yes? No, it won't be sections. It'll all be mixed. It's all going to be mixed in. Well, hey, there's no need to get frustrated because guess what? When you take that test on Friday, there's only one direction. Oh, I take it back. There's two directions that your grade can go. But what are the two things that can happen to your overall grade Friday? No, it cannot drop. That's the one thing it cannot do is drop. It can go up,
It can go
or
higher.
or it can stay the same. That's it. Okay. There won't be a column. There won't be a column on the gradebook for retake. It'll just be to replace any grade that you have that's lower than that. What? Any test grade. Any test grade. Huh? You like my belt? Thank you. I like your mask. All right. So
Why would he look at your belt? That is so weird. But okay.
Sam is a fashion guy. Sam's all about the fashion. Ferris wants to know what you think with belts.
I never said that. I said, why would he look? Oh, bro.
Mhm. I'll give you Ferris's contact information, and you guys can have a fashion talk.
I never said that. Stop saying something, bro.
All right.
Stop putting words in my
So
mouth.
the majority of this week, ladies, gentlemen, Sam, the majority of the week will deal with actually the equation of a circle, but we squeeze in a little bit of this density stuff beforehand. So what density is something that you're measuring. Okay, it could be apples, oranges, people. People is actually a very common measurement for density because when you measure people, what do you call it? You don't call it people. You call it when you're counting people. What's a fancy word for when you count people? What's a
Well, population.
Population. There you go. Caden said it. Population. So a very common measurement is population density. When you want to see like how many people are packed into a certain area, obviously like in this country, what what area of the country has a very high population density with a lot of people packed into a small amount of space. In this country, China would be. Yeah, New York. Sure. Well, California is a little more spread out, but see, like New York City would be the first thing that should pop into your head. New York City, because a lot of people are packed into a small amount of space. So it's some type of measurement divided by either a volume or an area, depending on what that problem calls for. Okay, so we go straight into word problems. For a certain species of animal to survive, the population density must be less than 15 per square mile. So 15, oh man, I can't even see here. 15 animals per square mile. A square mile an area or a volume? It's an area, sure. In a rectangular wildlife preserve measuring 20 miles by 15 miles, scientists counted 3,740 of the animals. Is there enough area for the animals to survive? So the area would be 20 times 15. What is that? 300 square miles. So the density is 3740 divided by 300. What does that give you? Calculator people? I'm getting 12.47 approximately. You got to round. Once you start getting into word problems, rounding, even if you're not told to do so, becomes more acceptable because word problems deal with measurements. And when you're measuring, saying 3740 over 300, that doesn't make as much sense as just rounding. So it's around 12.47. And it said that the population density must be less than 15 per square mile. So is that a yes or no? Is there enough space for them to survive? Yes. What's the reason? Because, sorry, it's hard for me to see here. Because 12.47 is less than 15. I kind of use symbols there to abbreviate because I was running out of space. If there is enough area, which there is, how many more animals could be moved into the preserve? If there is not enough area, how would you change? Yeah, but there is. So show how you found your answer. Okay. So let's find an equation. How many are we allowed to have? How many animals are we allowed to have? Yeah, we're allowed to have a population density of 15. Right now we have 3740, and they want to know how many we can add. In a word problem, when you have a question, that question normally is associated with the variable. That's what you're looking for. It's the unknown. I want to know how many animals. So let's just call that x. So the 3740 that are already there, plus however many we could add, and the area is not going to change. It's the same amount that we had before. So how would I solve for x? Multiply by 300, like they do in the hood. Yup. They even wear nice belts. I'm getting 4,500. 4,500 equals minus 3740. Now here's a little interesting thing. See, I'm getting 760. 760 equals x. But there's one thing that I did wrong. Did it say that the population density had to be equal to 15 per square mile? Less than. So I should have used, oops. I should have used where the mouth is facing away from the x. So really, oops, I can't see here. So x has to be less than 760. Can you have part of an animal running around? No. So if you want it to be literal and follow it to a T, how many more animals could there be? No, not 759. Yeah, because if you have 760, then you're not meeting the requirements. It's not less than. So any amount less than 760 would be fine. Once you reach 760, it's too many. Now, again, that's a very literal interpretation. Sometimes the people that write these problems don't really pay attention to what their rules are. So it's very possible that if this were like on a test or something, that you could see 760. So if you see 760 but you don't see 759, the heck with it, go with 760. Now, if you were to see both of them, 759 and 760, well, then you should go with 759. 759 should be the correct answer. Yeah. Any questions at home? Can't see you guys. Daisy's here again. Hi, Daisy. You didn't show up for the test, Daisy. Oh, speaking of which, if anybody, either at home or here, well, the people here did take it, but if anybody at home did not take the test on Friday, then you better be there this Friday for the for the retakes, and then that retake will replace any test that you've missed before. The area of Alabama is, our neighbors to the west, is 51,718 square miles, and its population is 4,779,736. The area, oh, I can't see there, of Mississippi, no, Missouri, ooh, sorry, I couldn't see it. The area of Missouri is 69,709 square miles, and its population is 5,988,927. The average state population density is 87.4 people per square mile. How do the population densities of so the average state, like all the states together, their average density is 87.4. So how do the population densities of Alabama and Missouri compare to the national average? All right, so let's do this. Let's do the density with a little sub A for Alabama. Density of Alabama is 4,779,736 over 51,718. 4,779,736 divided by 51,718, and I'm getting approximately. See, they had theirs to the 10th, so we'll do to the 10th also. I'm getting around 92.4 for Alabama. Lana, you're getting the same thing? Lana's quiet today. Everything okay? Are you mad at Mohammed? I'm mad at Mohammed. You did everything, man. What have you not done? So the density of Missouri is 5. Make sure you don't mess up you put the area has to be on the bottom. So the population is 5,988,927 over 69,709. 5,988,927 divided by 69,709. I'm getting 85.9 around approximately. Okay, so then to answer the first question, which is how do they compare to the national average? This is Alabama is higher than the national average, and Missouri is lower than the national average. Which is kind of weird because you would think at least Missouri has one of the bigger cities in the United States with St. Louis. But even though St. Louis is, St. Louis is fine. It's Kansas City. You know that half of Kansas City is in Missouri and half of Kansas City is in Kansas? Facts. The city of Kansas City, right? It's a border city. Like half of the city falls in Kansas and half of the city falls in Missouri.
I bet they had a weird complications when it comes to
Something like that. And now I think the more populous area is the Missouri side. So Missouri has St. Louis, and it has part of Kansas City. All right, is the population density of Alabama? The population density of Alabama is less than the average of the population. What? I can't read. The population density of Alabama. Are these like? Oh, is this multiple choice or something? Oh, okay. I was thinking that there were like 4 different questions. I was like, I know Alabama is not less. It's C. Okay, yeah. C sounds good. I thought it was like a 4-question thing. So sweet. Are you happy that it's Monday, Sam?
somewhat.
A company needs to package this bell in a rectangular box. What are the smallest dimensions, length, width, and height of the rectangular box can have? Why did this get cut off? I can't read. So that the lid of the box can. Did it get cut off in your printout, or you can see the whole thing? All right, so you can just write in the rest. So that the lid of the box can also close. All right. Well, see, what is the base of the bell? No, like what type of a shape is that? That's a circle, right? So a circle is the radius. It's the set of all points that are equidistant. So if it's 6 inches wide, it also has to be 6 inches deep. The diameter is the same going all the way around. The depth has to be 6 by 6. So what are the smallest dimensions you can have? Would be 8 by 6 by 6, so that it will close. Now, it doesn't ask about does it ask about volume, or does it part 2? No, that's a completely different question. If it asks for the volume, what would the volume be? Because it's a box, right? It's a rectangular box. So, like, what's another word for a rectangular box? Prism, yeah. So, 288, if they were to ask, okay. The question asks for the dimensions, though. I don't see anything else to answer there. 8 by 6 by 6 should be inches. Everything should be in inches there. A construction company is preparing 10 acres of land for a new housing community. The land contains large rocks that need to be removed. A machine removes 10 rocks from 360 square feet of land. About how many rocks will need to be removed from the 10 acres of land, and they give you a conversion. So there's actually going to be a proportion. So if population density is a fraction, what's a fancy word for a fraction? It starts with, no, close. It starts with R and ends with ratio. Yeah, a ratio. So the ratio that the machine will do is 10, the measurement is 10 rocks over 360 square feet. Well, now we need to project that. We need to see what the proportion would be. And they want 10 acres, so it would be this, if 1 acre is this much, it would be 43,560, but then with an extra 0 at the end, because you're multiplying it by 10. 10 acres. Because then that's how many square feet there are in total. And then look at the question. What are they asking? How many rocks? And as we talked about with word problems, typically what you're asking, that's what the variable will be. So I'll use an R for rocks. How do you solve a proportion? Cross multiply. So 360 times the amount of rocks is equal to 10 times that. So that's just going to be the 43,560 with an extra 0 now. Keep on adding zeros. Divide by 360 like the ninjas do. Like the ninjas, because ninjas slice and dice. So we're going to just slice it, that 360 right off. You like ninja movies? You don't like Kill Bill? That's like one of the best movies ever. I'm getting 12,100 rocks. There's 12,100 rocks that need to be removed.
Yes, we're all set.
Had a busy weekend working on credit recovery, Sam. Oh wait. Explain which geometric shape could be used to estimate the total amount of earth the mountain is made of. Yeah, a cone would be good. Like this kind of looks like a cone. What else could you make maybe an argument of? Well, I don't know about triangular, but some type of pyramid. I think you can make the argument for either one. Cone might be the best, but either one. A square pyramid is packaged inside of a box. The space inside the box around the pyramid is then filled with protective foam. About how many cubic inches of foam is needed to fill the space around the pyramid? All right, so there's going to be a subtraction problem. It's volume because we're talking about space inside. So the volume would be that of the box, which is just 5 cubed. But then we have to subtract the volume of a pyramid, which we now know how to do. volume of a square pyramid is one side squared, so that 5 squared times the height, which happens to also be 5, but then we got to divide by 3. So we end up with 125 minus 125 over 3, which if we did LCD, that would be, it'd be times 3. So that'd be, 375 over 3 minus 125 over 3, which gives us, 250 over 3. And then you got to round. Why is what so small? So I'm getting 83.3. Because LCD, this is 125 over 1, right? 1 times 3 is 3. What's 125 times 3? In order to subtract fractions, you need an LCD. You need an LCD. Now look, here's one thing that I guess you could do, right? Since this is a word problem, you're gonna round anyways. You can kind of get away with it. If you wanted to just go ahead and do the 125 divided by 3 as a decimal, so you could just do like 125 minus, and then do parentheses 125 divided by 3. It would kind of do it for you already on the calculator, because you know you're gonna round. 125 divided by 3 is 41.66, and then you could just subtract, but it comes out to 83. Any questions at home? Still haven't heard from Mariah today. Exactly. Who? Mariah, man. We have a girl named Mariah in our class. We've been had it. Diana's here too. Me neck hurts? Crikey. Christina is a toy designer. Because of manufacturing costs, she needs to consider the amount of material needed to make the toys she designs. She has designed a group of solid plastic toys with the given shapes and dimensions. Determine which toy requires the least material to produce. So I guess you just got to do all the volumes here and see what gives you the smallest. So the cylinder. So the volume of the cylinder is pi r, which is 3 squared times the height of 5. So that's going to be 9 times 5 is 45 pi. Do all of these have pi? No, they don't, so we're going to have to round. 45 pi is about 141.3. That's the first one. The volume of the cube. That's the cube is the cylinder. Volume of the cube is, that's an easy one. It's just 5 cubed, which is 125. Everything's in centimeters. So far, who's winning? Who's winning so far? The what? Anybody at home, you can still talk too. Can you guys hear me at home? Can somebody at least say something and acknowledge that you hear me?
Hear you.
There we go. So far, who's winning? No, woman. 141 is bigger than 125. So far, the cylinder's winning. Okay, now the sphere. You're right. Least amount. JK. I know you candy. How many do I know? Like 3, I think? 2? All right. 2 sounds better. You're right. She did say the least. It's the least. All right. So yeah. So far the cube is winning. So volume of the sphere is the radius is 4. So 4 pi 4 cubed over 3. This should be fresh in your mind. I'll just go ahead and put the whole thing in the calculator. That's really 4 to the 4th power times pi divided by 3. I'm getting 268.1 around there. So that's way over the top. That sphere is way too much. So the only thing left is the rectangular prism, and that one is simple. So volume of the prism, because you just multiply those, 6 times 5 times 4. And that gives me 120. So which one is the smallest one? These are cube, centimeters cubed, centimeters cubed. So which one's the smallest? The prism, yeah, prism. Determine the amount of wrapping paper needed to wrap a present in a rectangular gift box. Well, technically we haven't done surface area yet, but let's just do if this was a more complicated solid, then I would just skip it. But a rectangular prism is not too bad, and you guys have done area before. That was first semester. What? Who was that? Mariah, you said something? How many faces? How many faces does a rectangular prism have? Because now we're talking, instead of volume on the inside, we're talking about the outside. So how many? It has 6, right? And opposite faces are the same. So really, there's like 3 pairs. So like there's this little it looks like a square, but it's not, because it's 10 by 8. There's 2 of those, right? Then we have the top and the bottom one, okay? And then we have the 2 that are on the sides. So if you were to look at the formula for the surface area of a rectangular prism, it would be that there's 2 length times width plus 2 length times height plus 2 width times height. You're just taking turns multiplying those 3 groups. So like, there's going to be, and it doesn't matter the order, there's going to be 2 of the 8 times 10. There's going to be 2 of the 10 times 12. And then plus there's going to be 2 of, what are we missing? 8 times 12. And just add all that up. That formula just accounts for each pair. Like this here is the 8 times the 10. This here is the 8 times the 12. Up here on the top is the 10 times the 12. So you're just taking into account all of those. Miranda, calculator. Calculator girl becomes calculator woman. No, I got what? No, I got a much. 592. Well, then maybe I need to use parentheses. Let's see, 2 times 10 times 8 equals plus. Yeah, you're probably gonna be right, because plus 2 times 8 times 12. 592, you said? Yeah, okay. Area is 500. Surface area is 592. What would the unit be? Just curious. See, not cubed. It is centimeters, but even though it's a solid, it's an area. We're measuring a flat space on the outside. It would be square. Yeah, square centimeters. But the cubic is volume. Complete the problems below that involve figures within other figures. Fun. If each can has a radius of 2 inches and a height of 5 inches, what is the volume of the box? Okay. So if the radius is, because they're back to back, so this is a radius of 2. So this is 2. Like basically here better. If the radius is 2, what's the diameter of each of those cans? Is 4, right? So then this would be 4, 4, and 4. So the width of it would be 12. And then how many cans does it take to go across this way? 4 and 4 would be 8. And now the height of the can is 5 inches, so it's 5 inches going down. And they want to know what's the volume. So volume is just 5 times 8 times 12. 40, is it 480? Yeah. What would the unit be? This one would be cubed because it's a volume, but it's inches cubed. It's inches. They're measuring inches. Tennis balls. What is the volume of the tennis? What is the volume of the tennis ball can if each tennis ball has a radius of 1.5 inches? So if we have a radius of 1.5, what's the diameter of the ball? If the radius is 1.5, it's 3, because 1.5 times 2 is 3. So, now, let's look at the formula. For a cylinder, is pi r squared times the height. So I do need the height. Yeah, you are correct. The height is going to be 9. But then we don't need the diameter going across. We just need the radius, which is 1.5. So the volume would be pi times 1.5 squared times the 9. It doesn't really ask us to be exact or not, but since it's a word problem, we're measuring something. Let's just go ahead and just round it all together. Like 1.5 squared times 9 times pi. I'm getting 63.6. Is that what you said? Yeah, good. 63.6. And this would be cubic inches. What is the volume of the tennis ball can if each tennis ball has a volume? Ooh. What is the volume of the tennis ball can if each tennis ball has a volume of 33.5 cubic inches? See, the thing is that there's space in between, so you can't just do 33.5 times 3. What you're going to have to do is find the radius, just like we did here. It's awfully quiet at home. Not hearing anything at home. So if it's 33.5 is the volume, and that's equal to pi times the radius squared. Ooh. Times the height, but the height of a tennis ball is just 2 times its radius. You understand what I'm saying? Or actually, better yet, let's do this, because we're not looking at the can, we're looking at the ball. So let's use the formula for a sphere. 4 pi r cubed over 3. That makes more sense. Let's do that. And let's solve for the radius of the ball. So it'll be times 3. Is it 100.5? 100.5 is equal to 4 pi r cubed divided by 4 pi. So 100.5 over 4 pi is equal to r cubed, and then we take the cube root. Let's see if we can put that all into the calculator. 100.5 divided by parentheses 4 pi. That gives me about 7 points. It's almost like 8, basically. It's giving me like almost an 8. And then 3 root answer. I'm getting about 1.99. We can just round this to 2. It's so close to 2. And it's going to make it so much easier because I'm getting 1.999. So we can basically say that the radius is 2. So now that we know the radius is 2, how high is the tennis can ball going to be? Because now it's 2, 2, 2, 2, 2, 2. The diameter is 4. So 4, 4, and 4 is 12. Now the height becomes 12, but the radius is still 2. So let's do that over here. Volume is pi 2 squared times 12. And we'll just go ahead and round again because this is a word problem. It's leaving a pi wouldn't make sense here. Oh, and it does say to round to the nearest tenth. Perfect. I like it. I'm getting 48 pi, 150.8. 150.8. Perfecto. Perfectamundo. The decoration needs to be packaged. The slant height is 17 inches, and the base is a square with a width of 6 inches. What is the smallest size box that this item will fit to ship? All right. Yeah, we did. Because, see, watch, you'll remember it now. This is slant height, but we need regular height because we got to figure out about the package. If you take slant height, regular height, and half the base, what type of shape does that make?
A right triangle.
A right triangle. So they tell you that the slant height is 17. The square is 6 inches, so this is 3. What can we use to find the height? It's our good old friend Pythagoras and his theorem. Yeah, 3 squared plus the height squared is equal to 17 squared. So heights, let's do it in order. 9 plus height squared is that 289? 17 squared, yeah, 289. 289 minus 9 minus 9. Height squared is 280, which is not a perfect square. So we're going to have to round. Ooh, 280. What? 16.7 around there. 16.7. So what is the smallest size box that it will ship into? 16.7 will be the height, and we know that the base is a square of 6. So this would be 6 by 6 by, and 16.7 is actually rounding down, so I probably have to round up then and say like 16.8, because if it's 16.7 it won't fit, right? Because it's a little bit bigger than 16.7. Mo, why you bummed out, man? Is it because Lana was mad at you? She said she's not mad. She still wants to be friends. He's not exhausted. We're almost done. What volume of packaging materials would you need in order to fill the box from number 4 if you want to fill the extra space around the item? All right, so there's going to be subtraction again. Huh? Yeah, 6 by 6 by 16.8. Because I was getting 16.7, but if you do 16, like you have to round up. Even though rounding to the nearest gives you 16.7, because it's 16.73. If you go down to 16.7, you're not going to have enough space. You need a little bit more space. So now we need, so the volume is going to be the volume of this one, which is 6 by 6 by 16.8, which is, I'm getting 604.8, minus, because that's the box, minus the square pyramid, which square pyramid was one side squared, which is that same 6 squared times the height, which is 16.8, but then over 3. So, and we know from, that's funny, because we actually know from this before that this is going to just give us 604.8 over 3. That's the same 6.048 that you're getting. So, I'm getting 403.2. No, you're not getting that? Because 604.8 divided by 3 gives me 201.6. So 604.8 minus 201.6. And then if you subtract those, 604.8 minus 201.6. 604.8 minus is 403.2. And that would be cubic inches cubed. All right, we'll stop there. Tomorrow we'll get into the equation of a circle, which will be fun. Don't leave at home yet, because when I was having those technical difficulties, I didn't have a chance to take attendance.